I'm Andrea Ficchí, postdoctoral researcher in hydrological forecasting and climate services, and I'm working at the Politecnico di Milano in the Environmental Intelligence Lab, led by Professor Castelletti. And so I'm currently working on improving climate services for extreme events detection and forecasting, and focusing especially on a case study, the Zambezi River Basin in Africa. And so I'm working with a team of scientists on using machine learning techniques to improve hydrological forecasts in this region. I'm working on the Zambezi River Basin as a case study, and in particular we are focusing on this basin because it's a climate hotspot, so it's very relevant to study the impact of climate variability and change in this hotspot, because the Zambezi River Basin is particularly affected by extreme events, droughts in particular, tropical cyclones and related floods. So the Zambezi River Basin is a huge basin. It's the fourth largest basin in Africa. Its surface is more than 1.3 million square kilometers. So it encompasses 8 countries, and the 3 main countries that share most of its surface are Zimbabwe, Zambia and Mozambique. And so we are focusing on this basin because it also has very important socio-economic stakes, and the water resources of the Zambezi provide water for agriculture, irrigated agriculture. There is a huge area of irrigated agriculture that is key for food security in this region. Also, the water of the Zambezi provides the habitat to fishes. It's key for supporting the fisheries management, and also it has a very big potential for hydropower production. So it's actually used, and there is a large capacity, hydropower capacity in the basin. And we focus on these applications, on these sectors, to understand whether climate services and hydrometeorological forecasts can provide value to these sectors and users. So the Zambezi region is very vulnerable to these extreme events, and in particular this will be more and more important with climate change. So according to the 6th assessment report of the Intergovernmental Panel on Climate Change, IPCC, released last year, we are observing and we are expecting an increase in meteorological droughts driven by a decrease in precipitation over the basin, an increase in evaporation, and we are also expecting on the other side more heavy rainfall events driven by tropical cyclones. With these changes, we are expecting more and more impacts on the society, on the communities, and if we are not able to adapt to the climate variability and change that we are observing and expecting, then there will be more impacts and more damages to people, to society. That's why the work of CLINT is very important, because actually we are looking at shorter timescales than climate change. We are looking at climate services on a sub-seasonal to seasonal scale, and we are looking at established operational forecasting systems that already provide seasonal forecasts for water and hydrometeorological variables. So by using these services that already exist, we are estimating their potential to help in decision making and to better adapt to climate change. But on the other side, by trying to improve these services with machine learning, we are also trying to understand what benefits new techniques, new algorithms like artificial intelligence algorithms can bring to improve these services, and in the end to increase the adaptive capacity of society, organizations that deal with climate adaptation and climate solutions. So these organizations include national disaster management authorities, humanitarian agencies, the Zambezi River Basin Commission, ZAMCOM, with whom we work very closely in the project, and related users, because ZAMCOM provides information to member states and national agencies, hydrological and meteorological agencies, dam operators that take daily decisions to better manage the water resources by managing the big dams that regulate the flow in the Zambezi River basin.